I'm Ahmed Daud, and in this session, we are going to see what is the difference between parametric models and non-parametric models. So, before to start to discuss that difference, I want to elaborate what are the terms parameters and hyperparameters and what exactly the difference between them. So, multiple times I have used the terms hyperparameter and parameter. So, I really want to discuss that here before to start to discuss the actual lecture. And I really hope that you already know about that. So parameters uh, are the values of the model that model learn during the training process, and we can use that values after the training for the sake of prediction. And hyperparameter values that we have to specify before to start to build the model. Okay, so very simple example here you can see, like in this picture you can see there are some weights, W0, W1, W2, Wm. These are the weights, or like in the linear regression and logistic regression we were having some coefficient or some intercepts. These are the model parameters. And hyperparameters that we usually define in the classes of scikit-learn, how much iteration we should perform, what should be the penalty, what should be the CV, these values, what should be the alpha, these values, random state, these values actually the hyperparameters. If I will show you here in the documentation of logistic regression, let's say you have just two independent variables and you are going to solve a binary classification problem. So you will have three parameters, one coefficient, two coefficient and one intercept. Okay, so you have just three parameters. So this call the model parameters, and while on the other side hyperparameters, these parameters that are here listed all fall under the hyperparameters, in which there are penalty, dwell, tolerance, C, fit intercept, class weight, what should be the random state, solver, what solver you want to use, max iteration. All these values you have to specify to before to build the model. Okay, like in the when you have to decide what should be the best values for these hyperparameters, you can find by using grid search CV or some other technique, but you have to specify these values before the training process or before the model building part. And in the case of grid search CV, you are also specifying your values, because you are specifying some range of values, and each time you are passing each combination value to some model and build the model and check which model will give you some good result. Okay, so you can get an idea what is the difference between hyperparameters and parameters. Hyperparameters are the values that you have to specify before to start to build the model. Okay, so now come back and start to discuss about today's lecture, which is about the parametric models and non-parametric models. So in the context of statistics, parametric statistics, a branch of stats that always assume some assumption about the sample data. Like you have some data set, it assumes that your data set is coming some population which have some mathematical form that you can model by yourself. But on the other hand side, non-parametric stats don't make any assumption about the mathematical form of your data set. Okay, about the distribution or about the population distribution. What exactly the this is, you are very familiar with that. I will elaborate in a while. So in the context of machine learning, always in the context of machine learning, we are curious about to find the relation between our input variables and output variables. We always say that what relation actually exists, what function exists between our inputs and outputs. We are trying to find out or to estimate the function that can produce our outputs on the base of taking inputs. Okay, so this is main aim of a machine learning practitioner, to find best estimate of that particular function, what sort of function exists in our data set. So what is now parametric modeling or parametric models. Let's say you have here a data set which is a very simple data set in which you have just two independent variables and one dependent variable. Okay, so you have assumed that your data set, your input variables have some linear relation with the output variable. Okay, and linear relation have some mathematical form. Okay, so you assume that your input variables have some relation with the output variable which have some mathematical form, and you know, if you have made assumption about the linearity, then your mathematical form will be nothing like will be just like a linear regressor. Okay, so it will have like theta 0 plus theta 1 x1 theta 2 x2. Okay, so you are deciding that mathematical form on the basis of your assumption. Okay, now on the basis of your assumption you have decided that mathematical form, and you have limited your uh, number of parameters. Okay, so now just you have to find out the values of these parameters. Okay, because you have figured out and you have assumed that your data set has some linear relation, but what sort of linear relation is the linear relation like, uh, what what angles your linear relation have, what intercept your relation have, what sort of linear relation exists between your input and output variables. Is it like this, is it like that, or what type of linear relation exists in your uh, data set. You find out that by passing training instance during the training process, uh, and you find out the best values for these coefficients and intercept, or you can call these as a parameters. So this is nothing but just a parametric model. Okay, this is a model, this is a model, and during the modeling process, during the training process, you are trying to find out the values of their parameters. So uh, this model actually called a parametric model. Okay, on the other hand side, on the case of non-parametric models, you are not making any assumption about the relation, about the some mathematical form between exists between input and output variables. So what you will do, you just pass your training instance to your model, and you let all the responsibility to the model. That model will learn the pattern, learn the relation uh, between input and output variables by itself. You are not restricting the model above, based on your assumption. You are saying just I am passing the data to my model. Model has to learn what relation, what function exists between my input variables and output variables. Okay, so this is the basic underlying difference between non-parametric and parametric models. And you know, when you made some assumption, you are actually making when you are making some assumption about the mathematical form of your relation, then you are also restricting your number of parameters. Now, no matter how much values, how much training instances you will pass to that model during the training process, it will not increase or decrease your number of parameters. Your number of parameters will remain 3 in that case. Okay, theta 0, theta 1, theta 2. Parameter values keep on updating on the increase of the volume of training instances, but your number of parameters remain fixed that you have defined before to start the to build the model. But in case of non-parametric model, it is not this same case. In case of non-parametric model, you if you will pass some training instances, let's say 1000 instances to a decision tree, it will may have some different or some different number of parameters. And when you will pass some more instances, let's say 1 lakh instances to your decision tree, maybe it will have some different number of parameters, and it can have some more number of parameters, some for some feature like x1, and it can have a different number of parameters for some other feature like x2. Okay, so in case of non-parametric model, you cannot say that these type of models have not parameters, you can say that non-parametric models have no fixed set of parameters. Okay, so this is the underlying difference, and you can also differentiate your parametric and non-parametric models on the base of a set of parameters. Parametric models have fixed set of parameters, while on the other hand side, non-parametric models have no fixed set of parameters. Okay, so till now you got an idea what is the difference between parametric models and non-parametric models. Uh, One approach is that first assume some sort of relation, some sort of mathematical form exists between your independent variables and dependent variable, and then try to figure out or to finalize your assumed equation by using your training instances. What should be the parameter values? Okay, on the other hand side, which is non-parametric approach, is don't make any assumption, just let your model to find out what relation exists between your inputs and outputs by itself. Okay, so totally depend upon your training instances. So both approaches have their own advantages and disadvantages. We will see one by one. Okay, like in case of parametric machine learning algorithms, you already have assumed that your this type of structure, this type of mathematical form exists in your data set. Okay, you already have figured out what sort of relation exists in your data set. Now just you have to find out what should be the best parameter values. Let's say in case of linear regression, you have figured out that if your data set has linear relation between inputs and outputs, then you just have to find out what type of linear relation is this type of linear relation, this type of what should be the coefficient, what should be the intercept. Just you have to find out that. So that's why these are very simple and also interpretable. In case of speed also, you can say that yeah, you are not totally relying on your data set. You already have done your half work by assuming some mathematical equation. Now just your data will polish your mathematical equation and give you some sort of good uh, uh, direction of your mathematical function. Okay, so it also enhance your speed because half of work you already have done. Just you have to find out the best parameter values and less data, and the same the reason why you can find out the best model, best parametric model by using less data. Just data should be the relevant. The reason is that uh, you already know that this type of relation exists in your data set. Just you have to find out what should be the parameter values, best parameter values according to your training instances. Okay, and also there are limitation like here I have drawn. If you your data set have actually non-linear relation between inputs and output, and you are trying to estimate that non-linear relation by using a linear model, then you will underfit the your model will underfit. The reason is that it cannot be able to capture the pattern of non-linear relation. Okay, and you it also limited your power of your model, and this is also you can say it's a limitation that you have to figure out if your assumption is right, then you will get some good model, but if your assumption become wrong, then you are going to underfit the model. That is the constraint by choosing a functional form. These methods are highly constrained. Okay, you will when you have assumed some mathematical equation, you are highly depend upon your mathematical form. Okay, that is a constraint. And limited complexity. Let's say if you are like very complex data set and you are using very simple model, then you are not able to capture the pattern. Okay, And also it is really tough to find out what sort of relation exists in your data set, what sort of mathematical form exists in between your inputs and outputs before to start to build the model. If you made some good assumption, maybe you will get of course you will get some good model if you have some relevant data. But if you are making some wrong assumption, you will fall you will go towards the poor fate. In other side, in case of non-parametric models, also it has some pros and cons. But before to start that, to discuss parametric machine learning algorithm, logistic regression, linear regression, polynomial regression, softmax regression, perceptron, naive-Bayes, simple neural networks all fall under the parametric models. Because till now all the models that we have discussed all have some mathematical forms before to build the model. Okay, like in linear regression you have some equation. In case of polynomial regression you have some equation having some degree of the their input variables. And in case of softmax, again you have some equation in which you have some coefficients, intercepts. In case of logistic, again the same case. You already defining that this type of relation exists in your data set. Now you are going to find the best parameter values in the models that we already have learned. So all the models that till now we have learned all fall under the parametric models. Okay. So in the case of non-parametric models, it don't make any strong assumption. They are free to learn any functional form. You just have to pass the data, and the functional form, what sort of relation, what sort of pattern exists between inputs and output, it will try to find by itself. Okay, so non-parametric models good when you have a lot of data and you have no prior knowledge. You don't know what sort of relation exists in your data set, and in that case you can use non-parametric models. uh, and non-parametric models seek to best fit the training data in constructing the mapping function whilst maintaining some ability to generalize to unseen data. Okay, so non-parametric models try to find best fit relation between the your inputs and outputs from your training data, and also try to have the ability that it can generalize your unseen data, your new data points, your real-time data points. There are examples: decision tree, KNN. So in that particular module, we will focus on the decision tree, and you will get an idea how, without assuming some mathematical form, you are able to find out some relation or some patterns between inputs and outputs. So benefits, really they are very powerful and flexible, because you know you are not making any assumption. You are passing just the data, and model will learn by itself. So you can see the flexibility of non-parametric models, and also they have high performance. But the very you can say limitation of that non-parametric model, that they are very dependent upon the data set. So if you have less relevant data, or if you have less amount of data, and they can there are very chance that you will fall towards the overfitting part. You will 100% you will get the pattern from the data set that you have, but you are not able to generalize your unseen data. So you require more data, because you have to find out 100% patterns from your data set. Okay, and if your data that you have is defining half of the patterns, and half of the patterns your data set is not defining, then your non-parametric model will not able to generalize these type of data points when it will see in the future. And slower also, the reason is that it has no fixed number of parameters beforehand. It can have a lot of parameters when and depending upon the training instances, how much you are feeding the data to that type of model. It will learn the functional form, it will learn the relation between inputs and outputs, and also it is along the way it is finding its parameter values, both parameters and parameter values. Okay, so that's why it is quite slower, because it is feeding each data point very slowly compared to the parametric models, because in parametric models you have fixed and less amount of number of parameters. uh, if we will summarize both parametric and non-parametric models, the basic underlying difference is that parametric models make some assumption and then finalized that assumed mathematical form by feeding the training instances. And if you are making a right assumption and your assumption become or prove right, then you will get some good model, but if it become wrong, then you will fall under fit. But on the other side, on non-parametric models make few, or in simple terms you can say it will not make any assumption about the functional form of your inputs and outputs. So they have more power, more flexible, but again they are totally dependent upon the training instances. If your data is less relevant or have some irrelevant features or is not explaining the total patterns of the distribution, then it totally, and it can go towards the overfitting and cannot able to generalize your unseen data for now.